From the World Wide Web to the roads connecting our cities, networks are just about everywhere. In mathematics, random graphs are used to model these complex networks.
With random graphs, you take a set of objects and you are not told which ones are related, but the relationships come randomly.
Professor Nick Wormald is a world leader in random graph theory and one of Australia's most renowned mathematicians. While his work is largely theoretical, many of his methods have been used by other scientists to solve real-world problems. One of his major projects has been about developing a way to apply differential equations to random networks. While networks are made up of nodes linked together as discrete steps, differential equations describe continuously moving processes such as a car accelerating. Because of that difference in context, the two were rarely combined prior to Professor Wormald's differential equation method. But it turns out his method has many uses, including in the area of mobile phone communication. Messages are sent between phones as ones and zeros, and some of these bits can get lost.
The way it works is you send actually more information. So a very simplistic way of doing it is if you send every message twice. So then if one of the messages gets corrupted, you can use the other one. But that wastes too much space.
So a group of US researchers created algorithms that used random networks to make this process much more efficient.
Part of their research, they come to a question, well, what would this algorithm do on this network? How would it behave? Then they can throw in the analysis by the differential equation method and get some answers.
Other research he's done on how to generate random networks has also provided a robust framework for researchers to map and test their work in different networks and contexts. That's important, not just in telecommunications, but in other fields such as ecology and computer science. More recently, Professor Wormald also worked with collaborators on how to use network theory to optimise underground mines.
One of the intriguing questions that came up there was with certain constraints on how you can dig tunnels and underground mines, what's the cheapest way to make a network of tunnels that reaches a given set of locations underground? There are a lot of constraints on the tunnels, like a maximum angle they can be at for the trucks to drive up and down. But the version of the question I heard didn't mention underground mining. It was just, here's a problem. And the problem sounded interesting.
Interesting problems have driven the direction of Professor Wormald's research for decades now. He says there's nothing quite like the excitement of finally cracking a case. For his outstanding career-long achievements in pure mathematics, Professor Wormald has been awarded the Thomas Ranken Lyle Medal from the Australian Academy of Science.
This sort of recognition doesn't come along very often in a lifetime, so when it does, it really gives some sense of achievement.